Hey guys, so now we're into a lesson called factoring quadratics. We're going to take our quadratic, we've already done vertex form and standard form, and I'm going to show you how to do factored form and what it means for our parabolas. The first thing we're going to do is common factoring. So this is kind of the most basic way to factor. What you're going to notice in this example is that this one has 2x squared and this one is 10x. So what I like to think about is what is common between both of those terms, or what is the same in them. In this one, we can factor a 2x out of it, and this one has a 2x in it as well. So since both of those terms can be divided by 2x, we're going to pull that out. And then basically what we're going to put in the brackets is whatever's left. When you divide 2x squared by 2x, you have an x left over. And when you divide 10x by 2x, you have 5 left over. So that is common factoring. You just have to find something that's common between both of those terms and divide both those terms by that factor. Super simple. The second thing, this is probably the one that's kind of harder. What I like to do first is label these A, B, and C, and this refers to the values that are in front of the variables. So in this case, A is 1 because there's nothing there, B is 9, and C is 18. When we factor something like this, what we're going to do is kind of a two-step process, which you're going to first find values that multiply to equal C. And in this case, or in our case for the example, it is 18. The second thing you're going to do is find two numbers that add up to B, and they have to come from our set of numbers from step 1. So I'll just go through that with you. We're going to look at 18 and the factors of 18. So if I think about what multiplies together to give 18, I might think 1 times 18 is good, 2 times 9, or 3 times 6. Because this is a positive 18, we could also do the negatives. So it could be negative 1 times negative 18. That would give me positive 18. Negative 2 times negative 9. Or negative 3 times negative 6. So we end up having a whole bunch of sets of numbers that equal up to 18. The key is to find the one that adds up to this B value, and in our case it's a positive 9. So we just look at these different pieces here, or sets, and try to figure out which ones add up to 9. 1 plus 18 is 19, so obviously that one doesn't work. 2 plus 9 would be 11, that doesn't work. 3 plus 6, that equals 9. So that is the one we're going to use. Because 3 times 6 makes the 18, 3 plus 6 makes the 9. And then all you're going to do to factor this is set up two brackets, and we're going to use those values 3 and 6. So we'll make it x plus 3, x plus 6. Now, my favorite part about this, because we already learned how to multiply these together, is you can check to make sure the answer is correct. So if we just put it back into standard form, x times x is x squared, plus 3x, plus 6x and plus 9. You'll, not 9, 18. And then when we collect those two terms, they give us 9x. So you can see that you can easily check to make sure you did it right. Just expand and simplify again, and you get it back exactly what you started with, so we know that the answer is correct. Now, sometimes we have examples where the value in front, or our a value, is not equal to 1. Like in this case, there's a 4 in front. The first thing I usually do with this is common factor. So we're going to common factor it first, and I notice that all three of these terms that are out in front, or all three of the numbers, have a 4 in common. So what I'm going to do first is divide all three terms by 4. So I'm going to pull out in front. 4 divided by 4 is just 1, so it becomes x squared. Negative 8 divided by 4 leaves us with negative 2, and we'll keep the x there. And negative 16 divided by 4 is 15, negative 15. So now what we're going to do, we're kind of going to ignore the 4, and we're just going to focus on this part, and we're going to factor it the same way we factored our previous example. So I'm going to find two numbers that multiply to give us negative 15. So negative 1 times 15, positive 1 times negative 15. Because it's got to be a negative, it could be either one of those combinations. 3 times negative 5, or negative 3 times positive 5. And then, so we've come up with all our examples to equal that c value. So now we just have to add or subtract them to come up with our b value of negative 2. 1 and 15, that's not going to work in either one of those cases. But 3 plus negative 5 is going to give us negative 2. So this is the example I'm going to use. And again, we're just going to make two sets of brackets. And we're going to put x plus 3 into the one, and x minus 5 into the other. You might be like, hey Jen, does it matter which order I put it in? What if I had x minus 5 first and the x minus 3? Like this. And I will say, no, it doesn't matter. So if your friend does it this way, that's fine if you do it this way. They're both the same answer. In terms of multiplying, when you multiply it out, you should still get the same answer. Okay, moving on, there's a couple different different case for multiplying something that's called the difference of squares. Now the difference of squares just means that when you look at it, you have a squared value here. X squared is x times x, and you also have a value here, 25, which is 5 times 5. So they call this a difference of squares because we have this minus sign in the middle. So look out for examples like this. All you're going to do is come up with the values that these are squared by. So this one is x squared, and this one, the 25, is 5 times 5, so it's 5. What you're going to do is just put them in the brackets, x plus 5, and the other one is x minus 5. So they actually look the same. The only difference is that one has a plus sign and one has a minus sign. If you check it, it works out that when you multiply it, x is x squared, you get minus 5x plus 5x and minus 25. So you'll notice that these values in the middle, they will cancel out because minus 5 plus 5 just equals 0. And the check brings you back to x squared minus 25. So this is kind of a special case. Keep an eye out for it. I think I have some examples on the practice sheet for you. Now, you might be like, hey, Jen, I hate factoring. What is the point and why do we want to factor it? The reason is because the factors of a quadratic actually tell us where the x-intercepts are. And they have a special name called the zeros or the roots. So it's known by all different names, but just be aware they mean the same thing. So if I say x-intercepts, if I say zeros, or I say roots, it all just means the same thing. You're looking for those x-intercepts. You're looking for when y equals 0 in this case. So I'm going to go back to our example at the beginning. We've already seen this one and we already factored it in our second example. And we factored it to be x plus 3, x plus 6. When we want to find the zeros or the roots, we gotta take it one step further. And what you're actually going to do is find out when does this bracket equal 0 or this bracket equals 0. Because if either one of those equals 0, then the whole thing is 0, y is equal to 0, and the x, it will give you the x-intercepts. So I'm going to set it x plus 3 equal to 0, or x plus 6 equals 0. And the idea is then to solve it. All you're going to do to solve it is move the 3 over to the other side. So it becomes x equals negative 3. And the same thing with this one, we'll move the 6 over, x equals negative 6. So what that actually tells us is if we were to graph this, we know, first of all, the y-intercept is 18. And we get that from the standard version, and that 18 there. But we also now know that it's going to cross at negative 6 and negative 3. So negative 3 there. Negative 6. This parabola, because a value is positive, it means it opens up. So it's actually going to do something like this. It's going to come down. It's going to go through that negative 6 and negative 3, and then it's also going to go through that 18. So that is really the reason why we're trying to find the factors. Okay, try the practice stuff. Have fun. Let me know if you've got any questions. Bye, guys.